Okay, now this is the second part of completing the square. Um, it all the new issue here, and very important issue, is the idea that the leading coefficient is not 1 anymore. It's 4 in this example. Now, this example, I wrote it out so that it gives you a reward, if you will, if you're always always have in the back of your mind the principle of greatest common factor. That is the most important of the factoring techniques. And one reason is that, for example, in this problem, if you pull out the greatest common factor or divide by 4 in this situation, it comes out to the same issue. 4 is the greatest common factor of the left side. Well, if you do that, then you have brought the problem back to a nice, simpler problem with no special bells and whistles here. Now we're back to the kind of thing we did in the earlier video. Bring that 5 over to the right side. Here's the number 6. We need to find half of that, which is 3. Square the 3 and you get 9. 9 is the special number to bring in to add to both sides. And same process as before. The left side will become a squared binomial if we do everything right. The right side just comes out to whatever comes out. Take the square root of both sides. Don't forget the plus minus. And then we'll just be subtracting 3 from both sides and write out the answer clearly. It's very straightforward. But that was because in this case, the fact that our leading coefficient was not equal to 1, was 4, could be resolved relatively in a straightforward manner. As we'll see in the next problems, it's not always that nice, but in this case it was. And just in case you're wondering, if we had come to this point here, would the AC method have worked for factoring? In actual reality, no, it would not. I wrote this off to myself here. It's like, remember the AC method would take 1 times -5 and then factor -5. Find all the factors of -5 and see if any of those pairs add up to be +6, and none of them do. So the AC method was not an option in this problem. That was out. So we have to use some other methods. That's just the reality. Let's see. I think that is good for that example. And but I'll give you just a few seconds. You need to pause your video to write this out. That's great. And then you might want to have written the stuff down below, just in case I didn't give you enough time as I rush through these things. Okay, so now that was the first example of our more complicated situations. Now, the next example, here we are. Okay, very similar look to the earlier problem, and that was deliberate on my part. Yes, we have 4x squared plus 24x minus 3. Okay, we have to deal with that 4. You cannot do completing the square unless the leading coefficient's 1, and it isn't. So you have to deal with this. There's just no way around that. Well, what we do or can do is basically take whatever that number is, in this case 4, and divide every term by that number. So the procedure here is something along these lines. Bring the 3 over to the right side, but then face up to the fact we have to deal with the 4. Divide every term by 4. Now, at this point, after simplifying it, we have the leading coefficient of 1, which is what we need. In this case, we now have the 6 again. This is getting familiar. It's not always going to be 6, but in our examples it has been. And then, yes, we have this pesky fraction on the right side. Nothing you can do about it. Okay, they're going to be fractions. That's just, you can't avoid them. But the process here of calculating which number we need to add to both sides, exactly the same as before. It turns out to have been 9. And then, let's see, on the right side, we have to deal with adding numbers, whole numbers or integers with fractions. The computation work I did in red on the right. Don't know if you need that or not, but you got to get a common denominator. It's typical fractions. And then the same process. You take the square root of both sides. Don't forget the plus minus. And be on the lookout for perfect squares, because you take a square root of a number or a fraction which has a part that is the numerator or denominator that itself is a perfect square, it should be reduced. And that is, again, common practice, which I have followed here. But aside from that, let's see now. You brought the 3 over, subtract 3 from both sides, and then basically just write out the number explicitly as I have here in the box. I think that is the best procedure, because if you get used to doing that, you'll be used to thinking there should be 2 answers, and if there isn't, something is off. Something's not right about that. Give you just a sec if you want to pause the video. Let me get this all the way back at the top. If you need to pause the video to write this down, you can do that right now. And let's see, if you wanted to see what's down below, pause the video and write that down. Okay. So I hope this process is working. I'll give you a little bit of time. You can stop the video and see things to write things down. Now, there's only one additional thing I'd like to do with this problem, just to show you, is these answers look pretty darn complicated, right? I mean, this is pretty messy. And the claim is that, you know, one of these answers or both should work in the original equation up there. And, you know, does it really look like it would? So what I've done, and you don't need to write this down, but I just want you to see that this is no joke. I took one of the answers we had gotten, which was -3 plus square root of 39 over 2, putting it back into the original equation with a question mark as a check. You know, in other words, does the left side really work out to be equal to 0? And sure enough, after expanding out and canceling opposite numbers of each other and just continuing, grinding through all the arithmetic, sure enough, the left side does equal 0. Now, you don't need to write this down. I would never insist on this kind of complicated check. Wherever check steps would come up, I would leave them to be relatively simple computations. And this is not that, but I just want to illustrate that, no, you're really getting solutions. Okay, now next third, I think, example in this video. Here we go. Okay, so we have the situation of our quadratic 5x squared plus 9x minus 2 equals 0. 5, we have to deal with that 5, the leading coefficient. Bring the 2 over, the -2, I'm sorry, over to the right side. Divide both sides, every term, by the leading coefficient, by the a. Okay, in this case it's 5. So divide by 5, and you just have to live with it. And yes, I regret to say this is going to come up, that our b, or the linear coefficient, 9/5, you have to multiply that by a half in the process where I've been doing in green here. There's just no way around that. So it's simply a multiplication of fractions. Multiply the numerators together, multiply the denominators. Take that result, 9/10, and square it, 81/100. That blue number, 81/100, is going to go on both sides. It'll be added to both sides of the equation, which is what's happening right down here. Now, the right side, we have some fraction work to do here. I did this in red here off the side, getting a common denominator, and it turned out that 2/5 plus 81/100 is 121/100. Great. The right side, I'd be very careful to check this out here. X squared. Okay, x times 9/10, double that. The double of 9/10 is 9/5. And you can ask, and I can work that out if that's not clear. And then squaring 9/10 indeed gives you 81/100. So that all works out nicely. Everything is tidy. Take the square root of both sides. Don't forget the plus minus. It turns out that 121 is itself a perfect square. It is equal to 11 squared. And of course, 100 is equal to 10 squared. So the numbers can kind of be reduced there or simplified. And the rest is just subtracting 9/10 from both sides. And let's see, was there anything else very fancy here? Not really. I guess I combined like terms, I suppose. The fractions here have the same denominator, so I just continued simplifying that down to the final answer of 1/5 and -2. So let me, just in case you needed another shot at writing things out, let me just stop there for a few seconds. You can pause the video if you need to. then I'll come back down the bottom here just in case you need another view of that. Okay. All right. Last example for this video. Okay, there we go. So negative 3x squared plus 6x plus 1 equals 0. Right, so we have to deal with that negative 3 that's in the front, the leading coefficient. But what I would suggest is it is negative. It's a negative 3. And in my experience, having your leading coefficient be negative can cause all sorts of nasty problems. This can also be true of the quadratic formula. If you're starting out with a quadratic equal to 0, as we are, and you have this negative leading coefficient, the negative a, make it positive. Okay, and you can do that by multiplying both sides by negative 1. It's worth it. Getting this leading coefficient, getting leading coefficient to be positive will avoid a lot of nasty problems later on. So that's what I do here. And now with that done in the third line here, we're back to the situation as before. I'm going to bring the constant number, the negative 1, over to the right, adding 1 to both sides, divide both sides by the leading coefficient 3. And so with that done, here with this line here, we have the leading coefficient now being 1, so that's as it should be. And we have to compute the number to be added to both sides. So you take your negative 2, multiply it by a half. You're taking half of negative 2, which is negative 1. Square the negative 1, gives us a positive 1. So 1's the magic number that gets added to both sides of the equation. And with that done, the left side, again, is a perfect square. Notice there's x minus 1 here, not x plus 1, and it's all determined by the fact we had negative 2. We're subtracting 2x. The right side, I did the little computation work there, 4/3. Square root both sides. Don't forget the plus minus. Here we have a situation, well, a couple of things. One, the top of the fraction is itself a perfect square, 4. Therefore, we can compute that and should. That's just 2. Square root of 4 is 2. Then there's an additional little quibble going on here. The denominator is a square root of 3. And coming down here, how shall I put this? Well, let's put it this way. In the United States, we rationalize the denominator. In other words, we do whatever we have to do so that we don't end up with an irrational number like square root of 3 in the denominator. So in red, I went through the method we can do to get rid of the square root of 3. You basically multiply top and bottom by whatever that square root number is, and that will always give you a rational number on the bottom in the denominator. And notice what happens is you sort of transport the square root expression up into the numerator, and that's, okay. So I think otherwise, if I remember right, everything else is really very much the same. You're just going to bring the 1 over to the right side, and then please do express your answers 2 separate numbers there for clarity. And I think that, let me just bring this back up to the top if you need to do any writing from that part. And give you a second to pause the video. And now let me do one more shot down at the bottom in case you need to pause and write anything from there. And just one final little fun thing. Don't write this down, but what I did is, again, I checked the answer. I took one of our solutions, put it back in the original equation, and slogged through all the expansion and distribution, etc. And sure enough, it really does work as an answer, as a solution. 1 plus 2 times square root of 3, all divided by 3. That gives us 0 on both sides. So it does check out. Okay, I think that should cover it for, I hope, for completing the square. Thanks very much.